All right, for this very last section, we're going to just look at volume. I've only got 4 examples for you, so it should be much shorter than the last lesson. So you're going to solve for the volume of simple and compound shapes. If you know area well, if that brush up was enough to kind of make you, oh yeah, I remember how to do that, this should be quite simple. So volume is just the space that fills a 3D object, okay? So it has length, it has width, it has height, and units are always going to be cubed. You might also see, I shouldn't say they're always cubed, you will also see things like liters, gallons. But when we're using measurements in order to figure them out, we'll see centimeters cubed, meters cubed, millimeters cubed, those kinds of things, okay? So we'll see our measurement and we cube it. All right, so let's do a few calculations. I've got formulas listed here to the side, and we'll look at the formulas as we do our calculations. So first of all, we're going to start with a rectangular prism volume. So rectangular prism is just another way of saying a 3-dimensional rectangular shape. This is an example of a rectangular prism here at the top. Its volume formula is length times width times height. So we want to determine the volume of oil in a rectangular tank with a length of 1.2 meters, a width of 0.75 meters, and a depth of 0.25 meters. We want to give the volume in liters, and you've been given a new conversion. 1 meter cubed equals 1,000 liters. So to do our formula, we have length, width. Now this is a little trick that I was given when I did physics. I'm going to call it depth as height. When I did physics, we would always pull our units out and write what was given using variables and put them in our formula that way. That might be helpful for some of you. So plugging it into our formula, the volume is 1.2 times 0.75 times 0.25. In total, that gives us a volume of 0.225 meters cubed. Now we need to convert that to liters because we want liters at the end. So we're going to take the 0.2, oops, let me just erase. We're going to take our 0.225 meters cubed, and we're going to multiply it by our conversion. Now this is already cubed, so we don't need to cube it. The unit matches. So we're going to multiply it by, we want to get rid of the 1 cubic meter. Those will cancel. Multiply by 1,000. Leave us with liters on the end, so 225 liters. You guys have a large, out in the wind shop, there had been a large gearbox, and some measurements were somewhere was close to that. And I forget how many liters it holds. It is stamped on it, but we would always approximate it doing a volume conversion. The only thing was we didn't subtract for approximately how much volume the gears would displace, which is another calculation. All right, so that was a rectangular prism. Very, very easy. Length times width times height. You'll notice length times width is the same as taking the area of this face and then multiplying it by the height. Okay, so when we look at a cylinder, we're going to find it's similar. So the formula for the volume of the cylinder is pi r squared times height. Now, if you remember from before, pi r squared is the area of a circle. So we're taking the area of the top times its height. Okay, so area times height. You'll notice down here I have a general formula, area of the end times height. And that's basically what these all work into, because this is the area of a rectangle times height, area of a circle times height, area of the end times height. So that's will give us the easy formulas for them. So to determine the volume of fluid that can be held by a hose that is 28 inches long and has a cross-section diameter of 3/4 inches. So I find it helpful to sketch. So we've got this hose. We know its length is 28 inches. And then the diameter, we'll assume it's an internal diameter of 3/4 inch. All right? And we want to know what's its volume. So a hose is really nothing more than a long cylinder. So if I want to know the volume, I'm going to be equal to pi, 3/4 inches is 0.75. This is my diameter. Pi r squared times height. I need to figure out what the radius is. I have diameter, so to figure out radius is equal to diameter divided by 2, which is 0.75 divided by 2, which gives us 3.75. Whoops, 0.375 inches. So we're going to plug that in. Pi times 0.375 inches times our height of 28 inches, and just multiply the three of them together, and we'll find that we have 12.4 inches cubed of fluid capacity inside of that hose. Now you could look up the conversion for cubic inches to gallons or cubic inches to liters or ounces if you wanted to convert it further to a unit that you would actually usually purchase a fluid in. But now that once we have that, that's the hard part, to be honest. If you were in a pinch on the job site, you would probably use Google to do the quick conversion. Being realistic here, that's often what we end up doing. All right, and the last one we're going to do is just an irregular volume. So what's the volume of the shape shown in cubic millimeters? So rather than getting you to do more conversions, I've just kind of kept it simple. So this is an irregular shape, so it's neither a rectangular prism, it's not a cylinder, but it's a combination of the two. So we have a rectangular prism down here on the bottom with a half a cylinder on the top. Now we're going to use the formula down here, where volume is equal to area of the end times height. Now the area of the end is going to be the end that's the same shape the whole way through. So we're going to take this end here. Okay, if I took the bottom, as I cut slices on my way up, when I get up to this semicircular spot, I'm going to be in trouble because I'm not consistently getting rectangles. They keep getting smaller. But if I slice it this way, like a loaf of bread, every piece is going to be the same shape. So you can use that to help you figure out, well, what is the irregular end that I should calculate the area of? So we're going to calculate the area of this. So to calculate that, we need the area. I don't know why I draw triangles. The area of the square. So the area of the square is going to be 7 millimeters across here, and we have 8 millimeters going upwards. 7 by 8 gives us 56 millimeters. Now we need the area of the semicircle. I just discovered I made a mistake when I wrote my solutions up. It's all right, at least I haven't repeated it. Just as I'm doing this, oh darn, I forgot to do a division here. So we got a semicircle. We're going to find the area of this half circle. So we're going to find the area of what it would be if it was a full circle. And we're going to divide it by 2. So pi r squared divided by 2 will give me a semicircle. So I need to know what the radius is. So my radius is going to be half of the 7 because it's 7 from edge to edge. So that means my diameter is 7. So the radius is going to be 3.5. Okay, so pi times 3.5 squared divided by 2. And as we calculate that, we will get 19.24, yes. I forgot to put my squared on those. So we've got 19.24 millimeters squared. We're going to add them together. So plus 56. So 19.24 plus 56 leaves us with 75.24 millimeters squared. So the volume is equal to this area, the 75.24 times, this is going to be the same as my height. So height and length, height and depth. So that's going to be my height times 13. Gives me 978.1 millimeters cubed. Okay, and we could probably just go with 978 millimeters cubed. That would probably be fine. And that's all there is to doing volume questions. It's just taking areas. To be on cylinders are the most important ones. Circular geometry is probably the most important one. I know you need to know it for Jeff. You'll need to know calculating some stuff in Win 1005. No, Win 1000, I think it is, your Intro to Win course. So you'll have it come up in a few places there, and that's all we need to do for today.